adults grow new nerve cells? There is still some confusion about that question, as this is a fairly new field of research. For example, I was talking to one of my colleagues, Robert, who is an oncologist, and he was telling me, Sandrine, this is puzzling. Some of my patients that have been told they are cured of their cancer still develop symptoms of depression. And I responded to him, well, from my point of view, that makes sense. The drug you give to your patients that stops the cancer cells multiplying also stop the newborn neurons being generated in their brain. And then Robert looked at me like I was crazy and said, but Sandrine, these are adult patients. Adults do not grow new nerve cells. And much to his surprise, I said, well, actually, we do. And this is a phenomenon that we call neurogenesis. So now, Robert is not a neuroscientist. And when he went to medical school, he was not taught what we know now, that the adult brain can generate new nerve cells. So Robert, being a good doctor he is, wanted to come to my lab to understand a little bit better the topic. And I took him for a tour of one of the most exciting parts of the brain when it comes to neurogenesis. And this is the hippocampus. So this is this gray structure in the center of the brain. And what we know since already very long is that this is important for learning and memory, and mood and emotion. However, what we have learned more recently is that this is one of the unique structures of the adult brain where new neurons can be generated. And if we slice through the hippocampus and zoom in, what you actually see here in blue is a newborn neuron in an adult mouse brain. So when it comes to human brain, my colleague Jonas Friesen from the Karolinska Institute has estimated that we produce 700 new neurons per day in the hippocampus. So you might think this is not much according to the billions of neurons we have, but by the time we will turn 50, we will have all exchanged the neuron we were born with in that structure with adult-born neurons. So why are these new neurons important, and what are their functions? So first, we know that they're important for learning and memory. And in the lab, we have shown that if we block the ability of the adult brain to produce new neurons in the hippocampus, then we block certain memory abilities. And this is especially new and true for spatial recognition, so like how you navigate your way in the city. So we are still learning a lot, and they are not only important for memory capacity, but also for the quality of the memory. And they will have been helpful to add time about memory, and they will help differentiate very similar memory, like how do you find your bike that you park at the station every day in the same area, but in a slightly different position. And more interesting to my colleague Robert is the research we have been doing on neurogenesis and depression. So in animal model of depression, we have seen that they have a lower level of neurogenesis. And if we give antidepressants, then we increase the production of these newborn neurons, and we decrease the symptom of depression, establishing a clear link between neurogenesis and depression. But moreover, if you just block neurogenesis, then you block the efficacy of the antidepressant. So by then, Robert had understood that very likely his patients were suffering of depression even after being cured of their cancer, because the cancer drug had stopped the newborn neuron to be generated. And it will take time to generate new neurons that reach a normal functions. So collectively, now we think we have enough evidence to say that neurogenesis is a target of choice if we want to improve memory formation or mood, or even prevent their decline associated with aging or associated with stress. So the next question is, can we control neurogenesis? The answer is yes. And we are going to do now a little quiz. So I'm going to give you a set of behavior and activity, and you tell me if you think they will increase neurogenesis or if they will decrease neurogenesis. Are we ready? Okay, let's go. So what about learning? Increasing? Yes. So learning will increase the production of these new neurons. How about stress? Yes. Stress will decrease the production of new neurons in the hippocampus. How about sleep deprivation? Indeed, it will decrease neurogenesis. How about sex? Oh, wow. Yes, you're right. It will increase the production of new neurons. However, it's all about balance here. We don't want to fall in a situation about too much sex leading to sleep deprivations. So how about getting older? So neurogenesis rate will decrease as we get older, but this is still occurring. And then finally, how about running? So I will let you judge that one by yourself. So this is one of the first studies that was carried out by one of my mentors, Rusty Gage from the Salk Institute, showing that the environment can have an impact on the production of new neurons. And here you see a section of the hippocampus of a mouse that had no running wheel in its cage. And the little black dot you see are actually newborn neurons to be. And now you see a section of the hippocampus of a mouse that had a running wheel in its cage. So you see the massive increase of the black dots representing the new neurons to be. So activity impact on neurogenesis, but that's not all. What you eat will have an effect on the production of new neurons in the hippocampus. So here we have a sample of diet on nutrients that have been shown to have efficacy. And I'm just going to point a few out to you. So calorie restriction of 20 to 30% will increase neurogenesis. Intermittent fasting, so spacing the time between your meal, will increase neurogenesis. Intake of flavonoid, which is contained in dark chocolate or blueberry, will increase neurogenesis. Omega-3 fatty acid present in fatty fish like salmon will increase the production of these new neurons. Conversely, a diet rich in high saturated fat will have a negative impact on neurogenesis. Ethanol, intake of alcohol, will decrease neurogenesis. However, not everything is lost. Resveratrol, which is contained in red wine, has been shown to promote the survival of these new neurons. So next time you're at a dinner party, you might want to reach for this possibly neurogenesis neutral drink. And then finally, let me point out the last one, a quirky one. So Japanese groups are fascinated about food textures, and they have shown that actually soft diet impairs neurogenesis as opposed to food that require mastication, chewing, or crunchy food. So all of this data, where we need to look at the cellular level, have been generated using animal model. But these diets have also been given to human participants. And what we could see is that the diet modulates memory and mood in the same direction as it modulates neurogenesis, such as calorie restriction will improve memory capacity, whereas high-fat diet will exacerbate symptoms of depression, as opposed to omega-3 fatty acid, which increase neurogenesis and also help to decrease the symptom of depression. So we think that the effect of diet on mental health, on memory and mood, is actually mediated by the production of the new neuron in the hippocampus. And it's not only what you eat, but it's also the texture of the food when you eat it and how much of it you eat. On our side, neuroscientists interested in neurogenesis, we need to understand better the function of these new neurons and how we can control their survival and their production. We also need to find a way how to protect the neurogenesis of Robert's patients. And on your side, I leave you in charge with your neurogenesis. Thank you.
Fantastic research, Sandrine. Now,
Doing
I told you changed my life. I now eat a lot of blueberries.
Very good.
Right. I'm really interested in the running thing, okay?
Good, good.
Do I have to run, right? Or is it really just about aerobic exercise getting oxygen to the brain? Could it be any kind of vigorous exercise?
So for the moment, we can't really say if it's just the running itself, but we think that anything that indeed will increase the production or moving the blood flow to the brain, should be beneficial.
Right, so I don't have to get a running wheel in my office.
No, you don't.
Oh, what a relief. Okay, that's wonderful. Sandrine Thuret, thank you so much.
Thank you, Margaret. Thank you.